this function address, it will interpret it as the action that needs to be performed if you press the button. And because we passed the GTK quit function, if you press the button, the program will be ended and the window will be closed. So there's a fair amount to tell about this dialect example, and it has a number of constructs that are nested in each other, but it's still only 10 lines of code or something. And you could still object that this is not a real-world program. So let's have a look at a larger program with a fairly extensive GUI specification, the GTK widgets program, where you get an overview of all the widgets that are currently implemented in the binding and that are implemented in the dialect that I designed for Red System. And here you have a quite extensive declarative GUI specification where a number of different widgets are used, and they're nested in each other to get the layout that you want. And you will also notice that we haven't specified any padding sizes yet and any margin sizes. We have only specified a window size and a button size. And if you are used to a REBOL GUI programming, you wouldn't think anything of that, because in REBOL it is standard that if you don't specify margin and padding sizes, you will get default values that will look fairly well, and that you will only have to change if you really want to change your layout. But if you are used to programming GUIs in GTK, that will be fairly new to you, because GTK and many other popular GUI toolkits default to values of 0. So if you were to do this in a standard GTK program, all the widgets would be packed very tightly together, and somehow most GUI toolkits think that this is what you want. And in my mind, this is a sort of mathematical way to think about default values, because 0 is an elegant mathematical border value, but it's not really a very common default that you would use in GUI programs that need to look good. So REBOL takes a different stance, that default values should be the most used values in real-world programs. And I'm trying to implement the same concept in this Red System dialect by choosing default margin and padding values that look reasonably well. So I'm using default values for margins and padding like 5 or 10 or 4 in some places. And you don't see these values here until you run a program. So that means that most of these specifications are as compact as possible, because they leave out such values. And let's see if we can find one in here. I'm not even sure there's even one in here. I only see, there's probably only a margin and padding specifications in the table. The table widget as defined here, the first two integer values specify the table dimensions. So 2, 2 are the dimensions of the table, and indeed you see 4 buttons in there. And the two integers specify that they should be arranged in a square. But there are 2 more integers in there, 5, 5. and those are interpreted as the padding values between the cells, I think. And I think I did stay with the default 0 padding value for tables, because in many cases if you use a table you use it for layout, and so far my thinking is that in most tables you do want to have tight packing. So in this case I use, for tables I think I use a default padding value of 0, and in this case you want the buttons to be spaced, because you don't use labels but really buttons, just for this example, and the buttons look better with some spacing between them. So I think this is the only example in this layout where I use an explicit margin value of 5.5, and those are pixel values that define spacing. Let's scroll down to the bottom. Yeah, that's the only margin value that's really specified here. Now those are the examples, so let's try to compile one. Still says Red C library.
You need to get rid of
The Red GTK is in the wrong place.
Red C library and examples.
This should go. Yeah, the Red GTK should be deleted here. It should be at the front. The Red C library should be removed, because everything is at the level of the Red system folder. Right. Now we see our first hurdle. It is asking about a red glib file that we haven't seen anything about yet. Now if you take a look at the actual GTK plus binding, you'll see where this problem comes from. One level up. Here's the actual binding. It's an extensive binding, but it's in just one file. And then one page down, it starts with the includes again, and you see here that the GTK binding needs a glib binding. So now you see that we need to include the glib binding as well, so you have to download that too.
Red long side.
That's no problem, because it's standardized. And they not mentions that the glib binding is not yet listed here, but the names are standardized. So if you go back to the fossil repository and you change the URL from GTK to glib,
and this?
yeah. you'll find the missing glib dependency. Now this has a very short history, because it was originally in the GTK binding. Right, download it again. You know the drill already. This is actually what inevitably happens if you start binding your programming language to external libraries. There are many dependencies between them, like with the header files. And you can try to minimize them, but you still have to deal with these external circumstances. So you see that there was a hidden dependency in here that you're hitting, and now that you have installed the dependency, everything works. So the very nice thing about REBOL is that everything is included. If you download just the one REBOL view binary, you have a cross-platform GUI system included, and you don't have all these problems. But because RED is also meant to interface in a superior way to the external world, you have to choose. You can implement something like REBOL View for RED system, and maybe that will happen in the future. But you also want to interface with existing libraries and existing operating systems much better than REBOL is doing. But the trade-off is that you have to deal with the dependencies in the outside world. And one of those dependencies is, as we are seeing, that, for example, GTK depends on the glib library, and they're handled by the outside world, by third parties, as separate projects. So we also have separate bindings, because it's possible that you would want to write a RED system program using the glib library, but you don't want GTK. So I started by including the glib binding in the GTK binding, but when it grew a bit, I decided to split it off so that people can use the glib binding separately. But that means that you do have a dependency in GTK. Okay, try to start the program. Well, now we hit the next problem, and it's a dependency problem again. It's in Dutch, but it says that the program couldn't be started because the libgthread library is missing on your system. And again, this is because this is Windows. If you did this on Linux or FreeBSD, it's almost certain that it would be included. And the thing is that when you are dealing with these dependencies, you have to know what everything means. And it doesn't say that it can't find the GTK library, which you would expect. It first says that it can't find the libgthread library. And if you were to look in the GTK plus library, you would see that the libgthread library is actually a part of glib. So the first thing it can't find when you start this program is a part of glib, namely the gthread library. And in order to get this to work, you have to install all that on your system. And in this case it's extra problematic because you want to install this on Windows. So Ninat is now pointing towards where you can find the libraries to install on Windows. And indeed this is somewhat embarrassing, but that's because we are doing this workshop on Windows.
Go to download.cnet.com.
And then Ninat will walk you through installing GTK on Windows, because he's the Windows expert, while I take a short break.
Add CNET. We don't have the same first link. Okay, so we will now install the GTK Plus runtime libraries for Windows directly, then loading the package with the right binaries. Yes, this one. Okay. So 5 megabytes. Could be worse. You have it. Yeah. GTK Plus. It is this one, I think. Yes, this one. Okay, let's install it. Okay. Next. For the demo, we will install the libraries directly in the same build directory where we have our where we compiled our programs. So you can just copy paste the link from the Explorer, Red System. Take the wall. Click here. No, left. Click here. Copy and paste it inside the install. This one, the last one. Copy and add builds. Okay. Hope it should be in the right place, else we'll just copy the file manually. Okay, next. Yes. Yes, go. Full installation. Let's go, next. I don't know what's this conflict coming from. Maybe some DLL already installed. Maybe just rename the files to avoid conflicting with your already installed libraries. Next. Okay. Now we'll have to probably do a copy more. Just choose the language for GTK programs. Now you can set it to whatever you want. Okay. Now let's go back to the DOS console, the command line. Okay, let's see the layout of Okay, so everything is in bin folder. So the easiest way will be to copy copy the GTK widgets executable inside the bin directory, so we can launch it from there. Or you can do it from the command line. Just copy GTK bin. Okay, now you can cd inside bin folder, and you can try to launch GTK. We'll see if we have solved all the dependencies. So, okay, so it's searching for libgtk win32-2.0-0. Let's see if we leave it open so we can compare, and just open the...
It sounds like the wrong GTK version.
I don't know, maybe.
Which GTK version did you install?
GTK 2, but maybe 2. Oh, it's 2.10.13.
Ah, that's an old one. There's a few months ago there is a new Windows version of GTK was released.
There's a 2.24.
Yeah, exactly.
Is that the
You should
right
just
one?
go never install from weird sites. It's better to go to the GTK site, right?
Yes,
and then the Windows binary links to a certain other place, but it is a very recent one.
So we installed the wrong one. Oh, stable relays.
I think the last few years, I think 2.16 was standard, if I remember correctly. And now they've upgraded the Windows version to 2.24. 2.10 is really very old. So never install old versions. And with the new 2.24 release, GTK, there's also an updated Mac version, I think. And a lot of problems in the Windows and Mac versions were fixed. So it's actually, at this moment, it's actually quite a nice cross-platform GUI toolkit.
Okay, so now we need to search for the right package for Windows.
Not on I.
Try Windows, but I don't find any links. That doesn't include
Here.
installing Cygwin or other thing like that. So I know there's a package,
I think there was one package.
a small one which works without Cygwin or.
But isn't it here? I'm pretty sure I saw it.
Yeah,
okay. You need the all-in-one bundles. One more page down. Here, all-in-one bundles. See, 224.
Okay, try it.
That's the one. That's the new one.
Let's open it. Let's see. Just open it in the window so we can. See what's inside. Okay, so we just need the bin folder. If you can enter the bin folder. Okay. We should have all the required libraries here. If you can, we'll manually copy just in the bin folder we already have. So select only all the DLL file, okay, until the last one, and you need to drop them inside the bin. You can't copy paste, you need to drop it because it's in the from the. So you need to open the folder. Just remove the window, the error window. Close it. So
Okay.
we can see.
That's okay.
So where are we? We need to go back to the build red system builds folder. Red system builds bin. Okay, now you need to put both windows one. Yes, it's a difficult with maximized windows, but in Windows you can. Oh, okay. Won't work like that. Ah, okay, it's working. Cool. No, you shouldn't drop it on the exe file. I think it doesn't work. Yes. No, doesn't work. Yes. Just check the box and the first is it the first link? Replace and okay.
It's a weird dialogue.
Yes, absolutely. So let's get back to the DOS console and see if we fixed the dependency issue. Still not there. We are missing libpng 14. Let's see in the folder we've extracted this one. The bin one. Let's see if libpng is somewhere there. Seems you have missed these libraries. So same thing like before.
You do it.
There's a nice feature in Windows 7 when you can move the window just like that. No, it's not this one, it's this one. So you have now both windows, one on left side, one on right side.
Ooh, a poor man's styling window manager.
So you can now just drag and drop the files from left to right. Just, okay, should be good. Check, then first option. Okay, let's try it once again. Maybe you should close the error window first. Okay, let's try it now.
Whoa!
Whoa, it works. Now that all the dependencies are solved, the generated compiled binary is working fine.
Again, again, all this is usually unnecessary on Linux and BSD systems. BSD systems, once read, will run on them. Well, this is an overview of all the currently available widgets from the red system binding. Now there's a horizontal box in there and a vertical box with 3 buttons that look the same, but they say tight, expanded and filled. And those are 3 different layout directions. And when you resize this window, most of the buttons do nothing when clicked, but if you resize the window you can see how the different layout parameters work. Tight doesn't change the size of the embedded object. Expanded expands the cell but not the content. And fill expands both the cell and the content. And the quit button in the center does work the same way that we saw in the smaller example. It quits the window. And you started it from the console, right? So if you... here, interesting. The first thing we notice is that it has printed two warnings that I already talked about. The icon function can't find the icon file, which is a red icon that it would have used as the window icon. Subsequently, the window function notices, the GTK view function notices also that the icon object is missing. So you get two cascaded warnings.
It's not Linux, inderdaad.
/ right.
CP, copy.
Oh,
Yeah, copy.
This one. Just try to copy the. It's been. Okay, it's not there. It's higher. Red GTK. Test maybe. It's not already.
The red icon in the repository, you mean?
Red. Try red GTK.
Is it in the documentation directory or something?
Maybe
In
we'll.
the example directory.
Let's try it in directly.
No, I haven't checked the item into the fossil repository, so. But it may be in the documentation directory.
Red GTK. Example. Okay, we have it. So we need to copy it. Just copy it. And we will move it in the build bin folder just to...
Did you already put it in there?
No.
Oh, is it in my repository?
Just put... Okay. It's not very clean, but at least it will work.
The icon doesn't have a path, so the icon must be in the same folder as the executable. So we have the red icon now, which is you can see that it's used as the window icon, and it's also in the taskbar. And now we don't have a warning in the background. Now the other buttons that work are the two print buttons that are associated with the input fields. Just type something, doesn't matter what. Where did you get that from? Just type whatever. Okay, so you see that the print button is attached to the input field. And that is done in the specification of the GUI dialect. The hidden input box is meant for passwords. So if you write something in the hidden input field, you'll get dots or stars so that people won't see your input standing behind you. And you'll notice that there's no attached print button, but if you press enter, enter is also connected to a print function. And you can also do that in the other input field. If you go back to the input field that does have a print button, you can press enter there as well. And so the enter function of an input field is connected to a print function, and the print button is also connected to it. So there are two ways you can act on an input, by pressing enter or by pushing a separate button. And next is a multi-line input field with pre-installed text. So if you use the print button there, you're down. It will print a multi-line field, and you can also edit that. And if you see now, if you have more lines, you automatically get a scroll bar, a vertical scroll bar. And if you make a very long line, see, if you make the window longer, it disappears again. And if you make a long line, you get a horizontal scroll bar. And because the horizontal scroll bar takes space from vertically, you will also get a vertical scroll bar again, all automatic. And that's programmed in the binding, because a standard GTK multi-line input field will expand and it will push the window wider. So I added an automatic scroll function that adds the scroll bars automatically. And those are buttons that don't function. I made them a button to make them stand out better visually. And these are all GTK widgets, but some of the widgets are the same. And I made them different keywords in the binding to make them resemble REBOL View GUI specifications better. So maybe now it's a good idea to review the program again, to see where this came from. One back and the next, yeah. And what's interesting here is to see the different widgets and the different layout widgets, and the way the print button is connected to an action. So there we see a lines widget is the multi-line thing. And those have different names in GTK, but again, I try to conform to the existing REBOL names to make it familiar to REBOL programmers. But the fixed layout that you see under there, that's something that is not known from REBOL GUIs, but it is known in GTK. That's a fixed layout. And here it's a bit of a hack, but it's necessary to make the button conform to the size that is specified. If you say button 50 by 25, the button is still not fixed in size, and you have to fix it by nesting it in by embedding it in a GTK fixed layout. So there is some GTK stuff that is shining through in this dialect, and in red this will all become much more flexible. So in red it will be possible to make a dialect that doesn't leak through GTK constructs, and the dialect can be compatible across different GUI toolkits. That's what we aim to do. And the print function, you see again that here's a getLines function address passed with the colon notation. And there's actually an extra parameter, that's the lines at the end. And the getLines and lines constructs, in REBOL it would be possible to write them inline. That's not possible here in Red System, so they're predefined on top here. And in a Red dialect it will be possible to inline them. But now we have to look at the top to see the definitions. And there we have getLines at the top. GetLines is the callback function that we pass with the colon notation to the print button and the enter key. So getLines is the callback function that is executed when you request the action. And you see that the getLine function starts with a function specification that says cDecl. And that's the calling convention for the C standard. cDecl is what it's called in C. And yeah, maybe we should make that a more sane name. But this is the name that is known to C programmers. And the alternative is fast call, no, standard call, standard call. Which is really only used for the Windows system libraries. So even on Windows, because we're using the GTK library on Windows now, but those external C libraries, even on Windows, use the C calling convention. So maybe Ninat should rename that just to C or something. I don't know. But cDecl is the official name for it. So you have to tell the function that so that the compiler knows that this should be a callback function. And that's one of the low-level things that you can't hide from the programmer in low-level Red System, because you have to choose specifically between the C calling convention and the Windows calling convention. So this is the callback function that implements the action. And as we saw, there's an extra parameter behind it in the dialect, and we pass it the lines parameter. But the dialect knows that the callback function takes two parameters. So one parameter is added automatically, and the only parameter that needs to concern the programmer is the lines thing. And the lines thing is defined under there. We have two input fields, the single line field, which is called line, and the multi-line field, which is called lines. And those are defined as fields under there. And we pass in the dialect, we pass the lines field to the getLines callback. And in the dialect doesn't need to know how those fit together. But the dialect implementation in my binding knows that the getLines function actually takes two parameters, and it fills in the widget parameter automatically. And I think it also swaps them, but I don't really remember. But it does some GTK and glib magic to make it work. So you do have to have internal GTK and glib knowledge here to write your callback actions. But once you have the callback function, you can use them in the dialect in a very abstract way. Very REBOL-like. So programming Red System this way with a supporting dialect is really a mixed bag. You can, part of the functionality you can specify very abstractly in a declarative dialect, but some of the functionality, especially the processing functions and the callbacks, you still need to program in low-level terms of the library that you're using, in this case GTK and glib which includes GObject. And again, Red System does this at a very low level, which really goes beyond what C can do and other low-level languages such as C++ can do. But Red will take us fully to the same level as REBOL. But this is really quite unique stuff, which answers the question of why yet another new language. Do you agree?
Yeah. Okay, that's nice.
Yeah, I suggest we take a break in this workshop again. And Nenad has made, especially for this conference, a new demo in REBOL 2 to get acquainted with what REBOL can do, especially graphically. So that will give you an idea about what we are trying to match in REBOL functionality and what we have been working towards for a year now. But we're only, Red will really reach that level. So the REBOL demo will show you what we aim to do. And Nenad has assured me that it will blow you away.